Did you know the shirt you're wearing right now is an absolute recycling nightmare? It's true. We buy clothes, wear them, toss them in a donation bin, and just kind of assume they magically get turned into new clothes. But the reality of modern fashion is way darker. And the science of fixing it? Well, it is straight out of a sci-fi movie.
Get this. Globally, a staggering 75% of clothing waste hits a complete dead end. It just gets dumped into overflowing landfills or burned in massive incinerators. It's a colossal waste of resources, and it's happening every single second of every single day.
Future Threads, Growing Tomorrow's Cities from Today's Trash. In this explainer, we're going on a mind-blowing journey. We'll be diving into cutting-edge 2025 research that aims to solve this crisis, not by just making less stuff, but by completely reinventing what happens to our trash. We're talking about taking old, mixed-up fabrics and turning them into the actual building blocks of futuristic, sustainable cities.
To really wrap our heads around the scale of this problem, consider this. The average EU citizen generates 15 kilograms of textile waste every single year. Imagine a massive mountain of discarded jeans, jackets, and t-shirts just piling up in your living room annually. That is the sheer volume we're dealing with here.
Okay, let's dive into this breakdown because it is incredibly revealing. While 75% is trashed and about 24% is downcycled into things like cleaning rags, look at that tiny sliver. A tragically small 1% of clothing is actually recycled back into new clothes. Just 1%. So why is true recycling practically non-existent for the clothes we wear?
The mixed fabric flaw and why recycling fails. The answer to this massive failure lies in a major scientific roadblock. It turns out the very things that make our clothes comfortable, stretchy, and colorful are the exact things that make them completely impossible to recycle using traditional methods.
Think of a modern t-shirt like a baked cake. Once you mix together cotton, polyester threads, bright chemical dyes, maybe some stretchy spandex and metal zippers, you bake them all into a single garment. You can't exactly unbake a cake back into flour, eggs, and sugar, right? And right now, we can't easily unbake our clothes back into pure raw materials either.
Currently, recycling relies on manual mechanical sorting. It's slow, it's super expensive, and it requires perfectly pure fabrics like 100% cotton. But the holy grail of recycling? That would be futuristic chemical or biological tech that can literally eat mixed, contaminated textiles whole as one single stream without us having to sort a single thing.
Let's look at 4 sci-fi solutions being tested right now. This brings us to a groundbreaking 2025 study from Riga Technical University. Researchers rigorously evaluated the most commercially viable futuristic ways to process our mixed textiles. They scoured the scientific world for technologies that are currently in the testing phase but have the potential to change absolutely everything. They narrowed it all down to 4 mind-bending technologies. We're talking about converting old clothes into bio-oil, crushing them into advanced building composites, extracting pure microscopic crystals from the fibers, and finally, using living mycelium fungi to literally consume the waste. Here's the sci-fi rapid fire on how they work. Hydrothermal liquefaction basically melts your clothes under intense heat and pressure into raw chemical bio-oils. Isothermal hot pressing crushes mixed textiles and wood dust into super strong construction panels. Microwave-assisted glycolysis uses microwaves and catalysts to magically extract pure plastic crystals out of polyester. And fungal cultivation, it literally feeds your old shirts to living mushroom roots to grow entirely new materials. Seriously, how cool is that?
The ultimate test, multi-criteria decision analysis. But which of these is actually the future? Well, the scientists didn't just guess. They used a strict mathematical showdown called MCDA. It's essentially a high-stakes survival of the fittest test for emerging technologies.
A technology couldn't win just by sounding cool. To survive this test, it had to prove it was economically cheap to produce, had massive market demand, was technologically ready to scale up, posed 0 safety risks to factory workers, and most importantly, it actually had to lower our carbon footprint.
And this brilliantly illustrates just how staggering the results were. The chemical and melting methods scored surprisingly low because of high energy costs and safety risks. But coming in with a dominating score of 0.63, the ultimate futuristic solution is the mycelium-based composite. Biology literally beat chemistry.
The mushroom material miracle. Let's completely shift our focus to this awe-inspiring winner, dialing up the wonder of biological recycling.
We are talking about harnessing one of the oldest living networks on Earth to solve one of our most modern toxic problems.
So what exactly is this stuff? A mycelium-based composite is a futuristic biomaterial. Basically, you take shredded, unsorted, mixed textile waste and you feed it to the root structures of living fungi. The fungi release enzymes, digest the waste, and bind everything together into a solid, incredibly strong matrix. It is essentially nature's 3D printer, and its ink is our discarded clothing.
What is absolutely crazy about this process is the resource efficiency. 70% of the material's mass is grown purely from agricultural waste, things like grass cuttings and sugarcane bagasse, mixed directly with our old synthetic shirts. It requires almost no virgin materials to create something completely new.
Here is exactly why mushrooms crushed the highly advanced chemical competition. It is insanely cheap, costing just pennies per kilogram to produce. It taps into a massive €57 billion global insulation market. It uses zero toxic chemicals, meaning it is perfectly safe for workers, and its carbon footprint, microscopic compared to traditional plastics and foam.
And there is a real poetic brilliance to its final application. Tests proved this mycelium textile composite has incredible thermal properties. We are literally transforming a winter jacket, something designed to insulate a human body, into a living, breathable material that will perfectly insulate a massive building.
Building the future eco-city. Take a step back and envision what this tech means on a macro scale for the future of human consumption. We aren't just figuring out how to throw things away slightly better, we're discovering how to integrate human waste directly back into the natural biological loop of the planet.
So, the crucial point is this. Starting in January 2025, the European Union actually mandates the separate collection of all textile waste. Instead of shipping that waste off to landfills, this new mandate could directly feed massive fungal biofactories, seamlessly bridging the gap between fast fashion's worst habits and sustainable green architecture.
Grounding this sci-fi narrative back in reality for a second, the researchers note that this tech is currently at technology readiness level 3. It works beautifully in the lab, but scaling it up to industrial, city-sized biofactories, that is science's next great frontier. We have the blueprint, now we just have to build it.
It absolutely forces us to rethink everything we know about garbage. The synthetic mistakes of our past might just be the exact seeds we need to grow our future. So I leave you with this to think about. 10 years from now, will the walls of your future home be grown from the very clothes you throw away today?